You're listening to Cultivation Elevated, hosted by Michael Williamson and Anders Peterson, where we discuss vertical farming and the future of cannabis and food production.
Hey, what's going on, everyone? From Pipp Horticulture, I'm Michael Williamson, along with Anders Peterson, and you are listening to Cultivation Elevated, the podcast where we dive into all things cannabis, food crops, CEA, and vertical farming. Today, we're excited to introduce and share some insights on an ongoing airflow research study that Pipp and Cannabis Research Coalition are collaborating on, led by Dr. Allison Justice and supported by our very own Anders Peterson and Brian Tatrow. Allison, it's always good to see you. Thanks for joining us today.
Yeah, pleasure to be here. Thanks for having me.
I know that you're kind of a well-known player in the space these days, but if you don't mind, for anyone that's not familiar with you and some of your work, if you could give us kind of a brief overview of kind of your journey in this space and what's led you to kind of initiate starting the research coalition.
Yeah, so it's been a long journey. I think this year denotes 10 years being in the cannabis space. I was born into a horticultural family, so I've had a green thumb, just not necessarily cannabis green, for about 10 years now. But prior to that, living in South Carolina, I went to Clemson University, got a degree in horticulture, ended up finishing out with a PhD in horticulture. After graduating, I didn't necessarily know what I wanted to do, even still then. I wanted to do research. I wanted to stay in research. And so oddly enough, I started doing consulting for pest management, IPM, with, big box greenhouses growing poinsettias and, geraniums and that sort of thing. And eventually started getting some calls for IPM with cannabis. Being from South Carolina, I was hesitant, even though I appreciated the plant and what it does and use it, but didn't necessarily know what cannabis industry meant, especially if you're comparing it to the ornamental world. But jumped in anyways and did some consultations and absolutely fell in love with the plant. How many smells there were, how many types there were, really got into the effect of it personally and just absolutely fell in love with the whole idea. Being a researcher and there being a plant where there's not already a bajillion papers on it, was very enticing. I think it's not many plants that are out there, whether it also has this beautiful psychoactive part or not. There's very little plants out there that, a scientist can grasp and really be on the cutting edge of, being able to figure out some of those things and help the industry push forward with it. So anyways, moved out to California for about 4 years. Working in the cannabis space for a vertical farm. And that's actually where I started my relationship with Pipp. At the time, Pipp and Fluence. So I was working together with all of you guys to really look at light intensity and the use of LEDs, which at the time, even my own growers were telling me I'm crazy for wanting to, try, because for me it was like, well, why wouldn't we try this? I have no emotion tied to a type of lighting. So if it works and it allows us to go vertical because we couldn't go horizontal, then it's a win for everybody. And so that was very successful. Did the study, showed cannabis loves lots and lots of light. And at that space, we were able to go vertical. And so that, brought in a lot more revenue for the company. So, a very good example of how science can, lead to increased revenue because you're figuring things out and you're doing it properly. So
it's funny to note too, real quick about that facility you're at in San Diego was, I think, Pipp's second horticulture customer ever. It was right when Pipp Horticulture was really founded, that division. Similarly with Fluence, the release of those Fluence lights kind of made the vertical farming and close proximity lighting viable for the first time. It was a feasible strategy, and you were really on the cutting edge of it.
Yeah, it was interesting. It was one of those things where, you're trying to shake things up and, you go through the math and you go through the logic and it makes sense to do. But then, of course, you've got your naysayers saying, well, you're going to ruin this and that, and things work as they they do already. Why push things? And it was very rewarding to get through that project, because it was not all smooth sailing. I mean, everything from, Pipp being new and, going from a space of, holding goods that, just need whatever temperature, to be in a space where there's high humidity and you're delivering water from top to bottom, and all of those kind of hoops that the lighting, the racking, and everything had to jump through, on top of our calculations saying, well, you need more dehumidification. The management, they're not wanting to buy more dehus, doing a run, getting botrytis, saying we needed more dehus. The math says more dehus. So lots of, ups and downs with that. But at the end of the day, and 8 years later, they're still using this space and it's running smoothly. So absolutely worth it. But like with anything, a lot of trial and error.
Mm-hmm.
So anyways, I eventually moved back to South Carolina right when the hemp bill was, federally legal for growing hemp, and started the hemp mine with my family. At first we were just growing, and, I was breeding kind of just for our growing. The second I stepped into a cannabis facility, though, I knew I wanted to have some sort of hand in research, whether it was just as I did at Outco, where it was a combo, or, of course, my dream was to have a fully dedicated research facility. And so, because of South Carolina having hemp, I'm able to achieve that goal now. So we've created the Cannabis Research Center and Coalition, and I'm very excited to say, just a few months ago, we're open source. So, everything we do, we share, is free to cultivators. Everything from SOPs to multiple years of monthly talks, whether it's just research, general research, other people's research, own things we're doing, or bringing in a specialist and kind of interviewing and learning from them. We want to share. But we also do contract research. And so that's kind of how Pipp comes into play, and the relationship we've built together off of our previous relationship. We took our space, cut up an indoor space we already had, made it airtight, made it individually controlled, put in a lot of the bells and whistles to really look at airflow. And, I guess that's where we are today. And what we're here to talk about today is this project we're doing together.
I would like to jump in quickly and just kind of fanboy for a moment. As a cannabis scientist, I guess myself, and someone who's been interested in cannabis science since a young age, it was really refreshing to really learn about you 8 years ago when you were in San Diego, and some of the initial research you were doing. I was instantly drawn to it, and it was kind of a breath of fresh air from someone who came from cannabis, not from a traditional hort background like yourself, to see someone really applying scientific rigor to the process and really trying to answer the questions that I had been curious about for years, when my resources for these questions at the time were online forums and conversations at Cannabis Cups with people who were pseudoscientists. And so that level of scientific rigor was really quite new at the time in cannabis that you brought to the table. And it was exciting for me. And so I devoured anything you put out, whether it was with Fluence or with Alco or with Pipp or whatever. So coming full circle, being here at Pipp now and being able to collaborate with you on this airflow research trial has been just awesome. To kind of see how your brain works, to be involved in the process and learn from you. It's been really, really an amazing experience for me. So I'll stop my little fanboy moment here, but for people who haven't heard of Allison, which I think is pretty rare, she really has been an influential figure in cannabis research for many years, and highly respected. So it's just so cool to work with you on this.
I thank you for saying that. And, back towards you guys, you too, Brian, everybody I've met at Pipp has just been, top class. In their own niche and in cannabis in general. I mean, it's an honor to be working back with you. And so far it's been an awesome project. The collaboration has been wonderful. And I'm just excited to start this. I mean, it's been in planning mode for a little while, but we're growing things and we're doing things, and so I'm very excited to be working on this project with y'all.
Oh, well, thank you. And for me, it's been interesting. One of the main things I've been learning from you is the shift in mindset from commercial cultivation to research cultivation, and how different those two approaches really are. There's a lot of similarities, but there's also quite a bit of differences in terms of growing commercially versus research. Can you maybe touch on that a little bit and maybe explain your thought process and how you shifted from indoor multi-tier commercial growing to research cultivation?
Yeah, and my training in grad school certainly set me up for success, and shaped my mind of how to think about things. And ultimately it's all about holding constant everything you possibly can, except the treatments you're trying to change. um, and that's complicated. And when you're dealing with, in our case, we have 3 different rooms, and you're trying to hold everything constant: temperature, humidity, lighting. It gets complicated. But because we have GrowLink, and because we have sensors and equipment we can trust, it certainly makes it a lot easier. But things that it goes well beyond planning. We plan these rooms to hit certain set points, and then the high airflow treatment causes, just for example, say the high airflow treatment causes the plant to drink more, and so it's also using more nutrients. And so then you're looking at, well, room and two's EC is much different than each other, and so then you're adding water, which is adding fertilizer, and then your moisture content's different. So there's always just these little, I feel like I'm sometimes like in an airplane, and you're just like twisting these buttons and twisting these buttons, trying to keep everything, as even as possible. Because the goal isn't just to push EC, it's not just to push yield, and, keep individually rooms as good as they can. It's making them as equal as possible, where any differences we're seeing is simply from the change that we're wanting to apply to them. And then
Absolutely.
making sure that your reps are high enough to support statistical difference, going through this motion a few times, because we want to make sure that it just wasn't this or that. You do enough to where you work through the mess, to see the actual differences that you're wanting to see.
Yeah, it has to be repeatable, and that's a tricky thing to do. And I think a lot of cultivators, when Anders are kind of troubleshooting and consulting with cultivators, it's amazing how many variables they'll change. They'll have a problem and you're like, what are the recent changes that you've made? And there's a multitude of them, and it makes it extremely difficult when there's a multitude of change. And it's not just like focusing on removing or adding one element and then assessing. And so, it just makes it tricky. One thing that's interesting to me is, these cultivation facilities, a lot of them are like, oh, we've got an R&D room. That's what it'll be coin named. But I'd say like 90% of them are doing like no research or development, and they're basically essentially like pheno hunting rooms at best. And then they're not, and it's just so interesting. And so people don't realize how expensive it is to do true R&D and to put out a white paper. And so I think what you're doing at the Research Coalition is pretty incredible. And honestly, it's a lot more economical for someone who's trying to reach a goal by not having to do that in-house. And then also the fact that it's hemp type versus THC type is also helpful, just because it's a little bit easier to navigate from an expense standpoint and compliance standpoint on the ag side than it is on like a Department of Health side or something like that from a regulatory standpoint. So that kind of gives you a lot more freedom, I think.
Yeah, absolutely. And you're right. Research is expensive. If you're doing it at the numbers, at the reps, and depending the type of testing you're doing, it can add up. We do chlorophyll analysis for certain projects, and that right there, it takes my team of 3 let's see, how many samples was that I was running? 25 samples, and there were reps within those samples. That takes 3 days for us to do, almost 8 hours a day, just to run those samples. And so some of these tests we run, a lot will outsource. We don't have an HPLC, so certain things like, cannabinoid testing, or leaf elemental analysis. Some of those things we can outsource to like Clemson University that have, really solid programs to do testing like that for others. But then there's some like nobody's going to do chlorophyll analysis on hemp. I've certainly looked, because outsourcing to trusted partners is, can be a great thing, but yeah, depending on what you're wanting to understand, is it just yield and cannabinoid content, or are we going out and renting a photosynthesis meter that's $90,000 a year? So it all depends, and we try to be as deep as possible as far as what we're getting in the reps, and how far down the scientific path we can go. But yeah, it's expensive, and so
yeah, but it's almost more expensive for these cultivators to continue making the mistakes or running their rooms, their climate conditions or root zone conditions, whatever you're investigating at the time. It's almost more expensive to be making these mistakes in a larger scale. And so for a reasonable cost, I mean, yes, research is not cheap, but what you're learning can prevent and save so many growers. And the fact that you're open source and sharing this publicly ultimately will save resource efficiency across the industry. In some instances, maybe it could mean running the room differently that ultimately consumes less power and energy. Or maybe it's less labor or less inputs to the plant, which save environmental sustainability and a whole host of other things. And so by investing in a little bit of research, it can really make a larger impact. I mean, we've seen examples of private independent cultivation businesses conducting their own internal research, maybe at a deeper scale than some pheno hunting rooms, but it's rare. But then they don't share that publicly. And I think that's the difference. Is it's great that they're doing the research, but they hoard it for themselves, which I understand. You're a business and you've invested in learning that so you can have a competitive edge. I think what we wanted to do and what you've been doing with other people in the industry is let's come together, let's find the money to do this, and then let's put this out for everyone to benefit from, and not just one individual business. And that's kind of how this started. Sorry, go ahead.
I was just saying, yeah, it's for the masses. It's not just for one company to sit on and, until an employee leaves and tells somebody else. It's just hidden knowledge, which is great. Companies have to do what they have to do, but this is different. And so working with folks like you all who get that, and it's much more common for this sort of relationship, many times in other industries, being with universities. It's much more common to see a greater collaboration outside of cannabis. And I get it. Cannabis is new, and those companies that are doing things new and efficiently, they want to hold that piece, to increase their own sales. But ultimately, if we're going to be successful as an industry and it not just be those top X players that can afford their own R&D center, then facilities like this has to happen, because nobody can afford to do this degree of research on their own.
Right. And correct me if I'm wrong, but the way I've kind of looked at it is so many of these other crops, of course, they've been around for many years growing commercially, but the research really starts at the academia level. And then maybe private industry takes it in one way or another a little deeper to find something they're interested in. With cannabis, it seems like the research initially that came out of universities was more public health related, health risks, addiction studies, a whole number of public safety and public health kind of studies. Just in the last few years, we've seen more and more universities actually doing like agronomic research and plant physiology studies, and which is great to finally see that. But I think that you have filled that gap where businesses, vendors, interested individuals can come to you and say, look, this area hasn't been studied and we really want to focus on it. And there's zero literature information about it out there. And that's kind of exactly what we did was, along with our mobile racking systems, we sell an in-rack airflow system, vertical air solutions. And when it was first released, it was the first commercially available in-rack airflow system for multi-tier cultivation in the world, a manufactured solution. And over years, over 100 miles of ductwork were sold, 8,000 plenums, until about a year and a half ago, we decided to look at the feedback from the customers, look at how its system's performing, and revamp and redo that system. Long story short, we came out with VAS 2.0 that produced a significantly higher amount of airflow than the previous version at a lower cost. And for the first time, there's a system out there that is truly variable. We can provide different velocities of airflow to the canopy and change it throughout the course of the grow cycle. But then the question became, well, what is the right velocity, right? So we have a tool now that can give the grower variability in airflow, not just running a fan at 100% and hoping for the best, but you can truly vary that. But then it's like, well, what is the right velocity? You look at airflow research for other crops, and generally they say between, zero point 0.5 to 1 meters per second is acceptable. But a lot of those crops are grown at much lower light levels. And so it's a different airflow rate to balance the energy balance going on the leaf, the transpiration rate, the photosynthetic rate. And that's really kind of the genesis of how this relationship began. Was there was really no good information out there. Cannabis is somewhat of a unique crop in terms of the light levels it takes compared to other commercially grown crops. And no one really knows the right amount of air to provide it. I think we're past the days of my leaves are dancing or not.
Right.
And it kind of takes me back to one of the first studies I read of you of like whether to burp or not, right? Like
Yeah.
leaves dancing and burping, it's kind of a similar, like, well, is it right? Like, is that good enough, or can we get more quantitative with it?
Yeah, exactly. I mean, people grow great cannabis, period. So it's being done, it's happening, but at what point do we want to be is better than what's happening? Right. You've gotta keep growing, and you've got to keep hitting those numbers. And you don't know what you need to achieve until you test it, and you test it properly.
It seems like more people today are trying to push the maximum potential out of a plant, or they're on that quest, because it seems like you could almost group two growers in two different categories. It's kind of like I don't want to say a bare minimum approach, but like meeting minimum thresholds to grow a relatively healthy plant, probably average yield. But then you have other cultivators who are like, they're pushing. They're trying to like see how much can this plant take, how much light can it take, how much EC can it take. How do I get the greatest yield and the highest quality? I think with price compression and consolidated markets and even emerging markets, it has started to shift the mindset to how do I get the most out of my plant? Because that might be the difference between like success and struggle. But that being said, it's interesting that people aren't taking like a research based approach. It's a lot of like mimicry where they see someone doing something, could be online, could be in a forum, could be someone they're following, and they go, oh, they do it this way, and they're claiming these yields. And Anders and I talk about this a lot too. It's like if you're trying to be yield focused, the first thing you have to do is like define how you quantify grams per square foot and what's included in that, because depending on who you talk to, it's kind of all over the place. And it's like, oh, you're including trim in that, oh, you're including seed buds. And so there are certain elements of our industry that truly don't have like a true widely accepted standardization. And what I think is beautiful, what you're doing is, this open source idea is interesting because it's the concept of like all ships rise in the tide. And our industry needs this elevation probably now more than ever. And as you know, coming from traditional ag, farmers kind of help other farmers. There's always a competitive edge, and maybe they'll ridicule someone who has maybe one of their like row crops is a little crooked or something like that. They might haggle them at the local corner store or whatever. But I think cannabis really does need to adopt this research backed, not, kind of move away from like, I think, I feel, this is how I've always done it, to proven best practices, backed by science, validated multiple times and things like that. So I think the work that you guys are doing is super valuable. And I think we're all pretty glad to be a part of it. What are some of the things that you're most excited about? Because airflow, you know, Anders and I talk about vertical farming all the time. And like, yeah, at first, if you're new to it, it's kind of like exciting and stuff. But, mobile racking is not the sexiest topic, but airflow is also not the sexiest topic in the cannabis world. But we're quickly identifying that it's one of these areas that people aren't paying enough attention towards. And, we'll go into facilities and we'll do airflow mapping. Anders has helped me a bunch on airflow mapping and how to kind of make that as standardized and get it as accurate as possible with the right tools and the right kind of parameters and timing. But when I do airflow mapping at really any facility, it is all over the place. And you start to realize the amount of microclimates that exist in any single flower room can be anywhere from, I have a warm side and then kind of a neutral middle and then a cold side, or it can literally be almost like a checkerboard. I've learned of like good airflow, bad airflow, or good airflow, bad airflow in the same row within the same 8 feet in some cases. So I guess for you, why is airflow so important, and maybe why has it been neglected, really until recently, to be honest?
I think the first thing I would say why it's been neglected is because it's tricky to measure. As you were just saying, where do you measure? At what height? There's a million speeds you could put. So I think people are just kind of, they say the leaves are dancing, we're good. Obviously, if you apply too much, you're going to get, whipped plants and damage from that. And if there's not enough, your room's going to be really stagnant. So I think everybody's just kind of going in the middle and being happy with it. But I think, once we get through some of these trials, I think there's going to be some surprise, particularly with the heights of the plant and how much airflow can actually manipulate height, or I should say suppress height. It's known in other crops that higher air velocity produces shorter, stockier plants. I tell my crop specialists here, if you have a room where everything's perfect, lower airflow, you're going to keep growing. You don't need to make your cells, the outside of the stems. You don't need to put the energy in to make them more, resistant to air, because they have everything they need. So if you're applying airflow, you're going to get shorter plants. And so I'm excited to see to what degree that is. You'll also have different size leaves. If there's higher airflow, there'll be smaller leaves. If there's higher airflow, there's probably going to be smaller stomata, but a higher density of stomata. And so the plant is giving itself an easier way to shut down those air holes when it needs to. And so its abilities to survive drought better. Whereas if you're a plant, much lower airflow, even no airflow, everything's just kind of fat and elongated. I mean, really, the cells are. So I imagine we'll see a lot of that, and it'll be more interesting from a commercial standpoint, is how that translates to yield and to photosynthesis. Because you need to think about it kind of two ways. One, you've got air homogenization in the room. And so that's just, making sure that the air that's coming from one side is, getting to the other side of the room, which a lot of times is done through other fans that are above the racks or whatnot. And then, so you need to think about room homogenization, and then you need to think about breaking the boundary layer of the plant. And so that layer right by the leaf that you're basically refreshing in order to bring in the gases that the plant needs to take up. So getting that CO2 that maybe you're applying in the corner and making sure it not only gets to the plant, but those microclimates are broken to where the plant can bring that CO2 in, as well as release water. It needs to transpire. And so if you have really high humidity microclimates, it's not going to transpire. And so if you're restricting breathing inwards and outwards, the plant's not going to photosynthesize as well, and it's going to lower your yields. So that's what we got to figure out, is what is that sweet spot between whipping the plants and not having any airflow. And there's certainly a magic number which we can find.
Yeah, that's something I see quite commonly, to your point around like transpiration rate and the rate of nutrient uptake, and how that's so directly correlated to the airflow rate across the stomata. I do feel generally that a lot of growers are quite interested in the root zone, because I think almost subconsciously it's something as a grower you have hands-on with every day in terms of mixing up your nutrients and managing your irrigation strategy. And I think it's natural to then, because it's a day-to-day management thing, to focus so much on root zone management and irrigation strategy. And today, with pushing these high ECs and precision irrigation strategies, if you really can't get the most out of those strategies and your fertility program if you're forgetting about everything going on up top in the canopy, because it is so directly linked. I do see that a lot in facilities that have low airflow, but they're pushing high EC in a pretty aggressive crop steering program, that they ultimately get a stacking of EC in the root zone much higher and faster than they want. Mainly because, at least the theory is right that we're talking about, because they don't have that balance up top in the canopy in terms of airflow velocity and even in consistent leaf surface temperature. I think
Yeah.
it's easy to kind of, because it's airflow, temperature, humidity, because it's kind of invisible, I think it's easy to have it be out of sight, out of mind at times, where like with fertility programs and irrigation strategies, it's more tactile. I think, I don't know, that's my guess as to why it's
That's an
less
excellent
talked
point.
about.
That's an excellent point. I don't think a lot of people think of it that way. When I'm monitoring what's going on, I can see that. But if you're not doing it from different airflows and comparing that, it's just not going to be seen. And so you're right. I like to think about the plant as like a straw, right? You've got what's in the soil and you've got the stomata at the top. And so if airflow is coming across and breaking that boundary layer, causing transpiration to happen more, the more transpiration, the more, to an extent, the more transpiration, the more the plant's going to take up that nutrients, because that's how the nutrients moves is through that transpiration. So you're right. If you're getting extremely low air movement, you're just going to keep stacking in the soil, and you're eventually going to have to flush, perhaps. So it's going to be exciting in 2 years, 5 years, when we understand both of these parts very, very well. It's going to be cool to see.
For sure. And you and I have talked about this before too, but one of, for growers out there, one thing that would be interesting to look at in your garden is a common sign of low VPD, whether that's due to the combination of temp and humidity or low airflow, likely the combination of both of those, is you start to see kind of a yellowing at the top of your canopy. And many growers will look at that and say, oh, I have a calcium deficiency or a CalMag deficiency. I need to add more into my root zone. Ultimately, most of the time, these growers are providing sufficient calcium and magnesium into the root zone, but it's a mobility issue. It's a fact that your VPD is so low and you're not pulling those immobile nutrients to the top new growth. That yellowing is really a sign of low VPD or low airflow. And if you start throwing more CalMag at the problem, you're actually just going to make it worse and create more imbalances. It's something that we really commonly see in facilities is this, I have a CalMag deficiency. No, you have an airflow VPD deficiency is what's going on here.
Yeah, excellent point.
I think water use efficiency is another interesting concept with airflow. And we've even seen it as we're trialing. I mean, so we're in the midst of a trial right now. We have plants growing in the room. We have 3 different rooms, as she described, one of them being basically no airflow, or what we call 0 to 50 feet per minute. And then we have more of an industry standard airflow. kind of in the middle, and a higher airflow rate. So we're trying to go low, medium, high with our treatments here and see the difference.
How are you defining industry standard?
We tried to use that 0.5 to 1 meters per second, the most common kind of statistics that we see or metrics that we see put out in literature. So
Traditional hort. And what does that translate to in feet per minute?
Half a meter per second is 100 feet per minute.
Okay.
Yep. And so it's interesting to see just initially as we've started this trial, like Allison mentioned, plant height is definitely already something we're noticing. Leaflet size is definitely a big thing. And then water consumption too. I mean, I'm curious, like how much more often are you filling the reservoir, having to mix the tank for the high airflow rate room?
Rough guess without crunching numbers, I'd probably say it's drinking at least a third more.
Yeah, that's significant.
It is. It is. They complain because they're my growers because there's this one tank that they keep having to refill and the rest are okay. So it's definitely significant.
I mean, that's amazing right there too. Like, because we're doing this on a small research scale. Like, imagine multiplying that out across thousands of square feet of canopy. And by not paying attention to this one variable, like let's say you have too high of an airflow rate, you may be going through a third more water. And obviously for listeners, we'll get more quantitative with this as we analyze the results. So don't hold us to the third. But still, even just as a ballpark, it's pretty significant when you multiply that out at scale. And it's worth paying attention to these things for your water bill, for water use efficiency. Especially when it's so competitive and you need to be looking at your cogs to be competitive in today's cannabis market.
Right. And I'm excited once we get through this, we'll have, hard data to show, how much we're actually putting in the rooms, how much runoff we're getting. So we'll have, true calculations of usage throughout. And that'll be, I think, very eye-opening to be able to share.
It'll be interesting to see like the correlation to yield and if there's an impact there as well. So, that seems to be the one that really gets people excited. But, you would think if it's transpiring more, eating more, should have a greater yield in theory. Does that sound right?
Mm-hmm.
Potentially?
To an extent, I think if airflow is too high, right, you've got the stomata closing and then it kind of becomes a reverse situation. But yeah, I think that is sort of the trend we'll see.
And you put out some stuff recently. I guess not that recent, but this year. And I want to say, were you using an electron microscope somewhere?
Mm-hmm.
That imagery was wild. I've never really looked at stomata at that level. So that was like something I think that was a real eye catcher. So I guess, are there any tools that you're using for some of these trials that are available for other folks, or things that you're like, this is kind of unique, no one's really kind of put any information out with these tools, or is there anything like that you can share?
Scanning electron microscopes are multi-million-dollar pieces of equipment. I definitely do not have one. I'm lucky enough to be able to use the one over at Clemson University, which is just about 30 minutes away. But you can see stomata. They're oddly small in cannabis, at least compared to some other ornamental plants I work with. And there's different things you can do to look at stomata. I don't know if the everyday grower would, if there's necessarily used to do it, but it's certainly fun to do it. I encourage everybody just to get down in there with the stomata and see what you're growing up close, because it's a very different world. And understanding, I say mouths because it is the plant's mouths ultimately, but understanding how many mouths there are on a leaf, where they're located, it really helps you to understand the plant physiology and think about what's happening when I'm spraying foliar nutrients or, foliar pesticides, where to spray and why, it becomes a very complete story if you understand the plant on that microscopic level. So though I wouldn't encourage people to go out and try a scanning electron microscope, there's some pretty cool things you can do with nail polish and, painting a leaf and letting it dry, drying it very quickly, and then looking at that piece of fingernail polish that you peel off, look at it under a microscope and seeing, are those stomata open or closed? And so there's some cool things a grower could do with that. Maybe they think, let's say, for example's sake, I want to see if the stomata are closing at night or if they're open at night, going through, painting a leaf, looking at it under the scope, because it can take 30 minutes to an hour for a stomata to close naturally. So theoretically, it should be as is. And yeah, that's one thing I would encourage everybody to do. Maybe not consistently for an experiment, in a commercial grow, but just to wrap your head around it and just to expand your understanding of what's going on with the leaves.
It's funny you mentioned that one. I actually was a friend of mine is an elementary school teacher, and they have a garden there at their school. And she asked me to come in and just talk to her class, fourth and fifth graders, about plants, basically. And so I was trying to think of a fun little experiment to do for the kids, but also had some, science to it. And photosynthesis is obviously a common topic, I guess, as you're learning about plants as a kid. And I wanted to introduce stomata and transpiration as well. So I took Elmer's glue and painted the bottom of some tomato leaves, let it dry in the sun. We had the kids peel it off, and then they used like graphite, like pencil dust, sprinkled it on the Elmer's glue, and then I brought my little USB microscope in and projected it up on the classroom for them to all look at it. And their faces, they thought it was so cool. It was a fun little experiment, even to do with like fourth and fifth graders, just to show them it.
Absolutely.
Yep. Allison, could you touch on, back to the trial, can you touch on some of the data that we are collecting and maybe like why we're doing it and kind of what tools you're using?
Sure. Well, we, of course, I'd say the most important one that we have in the rooms is anemometers. And so we have multi-directional or unidirectional anemometers, about
Omni.
We have about 4 of those per room. And so they're averaging the airflow. That way we can, have high precision of what we're actually applying. We're taking temperature measurements of the leaves to understand, with these different airflows, how is that changing the temperature of what's going on in your canopy. And that, of course, is relevant for lots of reasons. Temperature can change if the stomatas are open or not, all going back to producing high photosynthesis to produce yield. We like to see these things, kind of the nitty gritty, the up close, things that maybe a commercial cultivator wouldn't measure, and ultimately leads to the big difference being yield. But because we're plant nerds, we like to understand, a few of those metrics prior to just being yield. And it helps explain things a little more. We're looking at height, so weekly height measurements, and we'll be able to track that over time. As mentioned before, water use efficiency, so understanding how much water we're using, which then we can actually back calculate and understand how much fertilizer we're putting in. We, related to that, we're taking elemental leaf samples, so every week going through the different treatment rooms, taking samples of the same maturity and size, and sending that off to see, what is the plant actually taking up. Obviously, that uptake will then, again, convert later to yield, but it's important we understand that, to the amount, to the extent of where we can say, all right, well, in high airflow, we're getting, excessive uptake of nutrient X. So that'll really give us a really nice picture of, potentially what's over accumulating. And it'll help us understand down the road, if you have a really high airflow treatment, if nutrient X is, over accumulating, but everything else is going well, maybe the next run we back off on that specific input, that specific element. So let's see, what else are we doing? Leaf size. So I've got a pretty cool scanner that we can scan individual leaves every week, and cool AI tool that comes in and calculates leaf surface area as well as length and width. And so we'll see that over time. Of course, yield at the end, cannabinoids, terpenes. Let's see, what else am I missing, Anders?
I think I think other than just the data we're collecting from the GrowLink sensor, so basic air temperature, humidity, CO2, and then we also have some root zone sensors in there measuring root zone EC and volumetric water content. But no, I think what you covered there is really what's going to give us a good picture and idea of how airflow is affecting all these different aspects of how the plant's growing. I can't wait to see all these results and dive into it with you. It's been really exciting.
It's exciting, but like research is slow, right? It's like it has a pace because of the repeatability standpoint. So it'll be like exciting to see this first run results, and then it's like, all right, like how I guess the next step would be to try and replicate it as identically as possible, and then hopefully see the same results.
That's
I
it.
guess what happens when you're like, okay, like, environmentals were the same, irrigation strategies are the same, and there are certain things that are maybe not the same in the results. I guess, what's the scientific mindset? Is there certain outliers that get kind of cut out or trimmed out and you look at averages, or kind of, I guess, walk me through that. I'm a bit novice in terms of like how research works at that level.
Yeah, so the goal is to have so many replicates that statistically those outliers are, I don't want to say dismissed, but the average accounts for those outliers, and so they're minimized, I should say. They're statistical techniques that take that average and give you standard deviation or standard error. So it includes those ranges, but really what you're looking at is the average. So, it's accounted for, but with enough reps, you have that true average to give you an answer. So, for example, if we do 2 reps of these same 3 air treatments and we get statistically similar results from those 2 different timelines, then we can be confident in not having a 3rd round. Or if, for example, the results are backwards with 2 reps, then, well, yeah, you should probably do a 3rd, if not a 4th, to understand, to clear up a lot of that grayness that's within the data by having those reps that are significant. It's all about the statistics.
Yeah. The variability in like plant research is quite challenging. I mean, there's just so many variables that go into it compared to something that's more input output based research. I mean, it's quite interesting. And I'm as I'm learning from you and watching and kind of observing here, working with you on this, like things are surprising to me that are jumping out, or like I'm getting almost over my skis a little bit and having to learn patience with some of this, right? Too, because like even the leaflet size discussion with how airflow can affect the morphology of the leaf, whether it's skinny or fatter. One of the common discussions today that growers are optimizing in their garden is how do we get better A to B ratios, and how do we get bud size to be all the same, consistent, deeper into the canopy, whether you're using inner canopy lights or not. In this case, if you're not using inner canopy lights, like does that thinner leaflet allow greater light penetration as a secondary benefit, right? So there's all these other follow-up questions that start spiraling, I think, as you get further and further into this, that just make it, I think that's where my passion lies, is just the endless rabbit hole of what cannabis is and growing cannabis becomes.
Yeah, absolutely. No, that's an excellent point. Thinner leaflets allows more light through, and if the yields are just as well, that's an amazing trick. It's much better than in sun patients. part of my grad work was looking at sun patients and having them be more compact without using a PGR, a plant growth hormone. And phosphorus is one of those nutrients that can cause a plant to expand and really kind of grow out of control. But phosphorus is also what is very beneficial for flower formation. And if you're a sun patient, like, that's all that matters, is that you have pretty flowers. So tricks like airflow are a lot less damaging than restricting phosphorus for 2 weeks, just for example's sake. So there's lots of tools and tricks we'll be able to learn, I feel, with this information that are going to be very valuable.
Yeah, I agree. Well, as we kind of wrap up here, kind of like to end on like a fun note, I guess, if we can. And one of my questions to you, which is maybe aside from this research trial, is what is one of your favorite cultivars you've ever grown or bred? It can be hemp or THC based. Just kind of like a fun question there.
Okay. Well, I just got my highest test result ever. I don't believe it. But it hit 42%. Like I said, I don't believe it, but even if it's 32%, I'm excited. And it's not just one of those things where I shopped for a lab and, they gave me a good test result, because I got a lot of buds from this same run as well, 12%. But it's a 1-to-1, and it smells like absolute heaven. About 2.2% terpenes, grows really beautifully, looks like, a type 1. But the coolest thing about it, besides just having a really great stamp of approval from a lab that I don't believe, but besides that, when you smoke it, the first, at least for me, on what I have, the first third, or I'm going to say the first 2 puffs, you get a flavor, and then it just becomes a smoky flavor after that, because the smoke is literally running through it all. But where this one, I can get through probably half the joint, and it's still just as flavorful as it is at that first part. And so that's what blew me away, besides it just testing really high. That was exciting.
I got one for you too. That's interesting though. There are those certain cultivars where they're like tasty all the way through. Normally, if you're snobby, you kind of get to a certain point, you're like, I'm good. But then there's those tasty ones where you're like hitting that roach extra hard, because it still tastes good. I think Trop Cookies is one of those for me. If funding and regulations weren't a constraint, what's one experiment you'd love to run in a cannabis cultivation?
That's a good question.
Thank you.
Funding was a constraint.
I have a lighter one too, if you want the lighter one first.
I'm on a journey right now trying to understand what makes a good smoke, besides cultivar dependency, besides terpenes, physiologically, the trying to mimic the studies that have happened with tobacco and putting them into cannabis, chlorophyll content, sugars, yada, yada. All of that testing is extremely expensive and tedious. So if funding were not a problem, I would dig even deeper into that. I'm digging pretty deep, but I would take it to that next level.
And this is, you're referring to the science of smokability that you've been working on? Is that what you're referencing? Or is this something else?
Just generalized understanding what's happening in the drying cure.
Nice.
Which could, in turn lead to part of the science of smokability. But yeah, just wanting to understand what's going on.
Well, I know that cannabis is a never-ending conversation, but I know everyone's got a limitation on how much they can listen to in one setting. On a positive note, we are looking to, you can consider this an airflow research trial series, and we'll be having Allison on, I'd imagine probably like every 3 months for forever.
You're locked in now, Allison.
But yeah, if you like what you heard today, we're just getting started. And I think if you can't tell, the team here is very excited to share this information with with the world. And that's pretty exciting. It's not every day that you get to pioneer in anything really. And so it's really cool to kind of be a part of this journey with you. And so that being said, thank you so much for your time today. Always looking forward to the next conversation, and I wish you a wonderful weekend if I don't talk to you.
You too. Thanks for having me.
All right.
Thanks
Talk
for
to you
joining
soon.
us today, Allison.